Hi everyone, welcome to my YouTube channel. Today we will be discussing one of one of the very important low-level design problems that is asked in interviews in Amazon, Apple, Nutanix, and many other top companies. Right. The problem is to design the Amazon locker system. So the problem statement is as follows. You are to design the Amazon locker system where customers will customers order their products and the products are delivered by a delivery partner to the nearest locker junction, right? So what is a locker junction? To define locker junction, a locker junction is a storage space which is present across the city, right? A city can have multiple locker junctions. And in order to save cost, what Amazon does is they can deliver the products which are ordered by the customer to this locker junction, and the customer's delivery partner will deliver that product and store that package in a locker junction locker. There will be a locker, right? And the lockers are OTP enabled. So the delivery partners will have to enter an OTP that is inside they have to enter an OTP on the assigned locker for a particular package, and then they can store that product in that locker. Customers on the other hand, will be able to pick up their orders from that local junction. They have to enter a different OTP that will also be sent to their uh, order notification. As an order notification, they will also receive an OTP and they can enter that OTP to unlock the package from the locker and pick up their parcel, right? So upon emptying of the locker again becomes available to place another package. You can spend some time, you can pause the video here and check on how you can think about the core entities of this problem and how you will define the problem going ahead. Okay, now that you would have already thought about the problem, let's start with defining the core entities of this problem. So in a low-level design interview, how you approach the problem is you have to first define the core entities of your problem statement, right? Core entities are basically the actors, right? They are basically the actors who are involved in performing the operations in the system design. So in our case, we have a few major core entities here. One is the locker junction, right? Uh, like the orders will get delivered to a locker junction. Inside a locker junction, there will be multiple lockers, right? Lockers will contain orders, right? They will contain a package, right? Then there will be a delivery partner who basically delivers the orders to the locker junction. And finally, we will have a customer, right? So these are the more important core actors or the core entities of our problem, right? So what will happen is users will place an order, right? The delivery partner will have an order, right? Right. And the delivery partner will have a locker junction location where they have to go and place the order. Locker junctions have a locker, right? Where the users have to place the order. Lockers will have a OTP, which the users or the customer or the delivery partner can enter to put the package inside the locker or pick up their package in case of a customer, right? Okay, so these are the core entities that we have defined. These are the actors, right? And this is the workflow on how it works, right? Order will be picked up by the delivery partner. Delivery partner will basically check the locker junction that is assigned to a particular order. Inside the locker junction, they will have a locker which is assigned, like locker number could be 1A, or something like that, right? For the locker, there will be an OTP that is assigned, right? So this is the overall flow that we will be going ahead today with. Right. So now let's define after you have defined the core entities and the flow of your system design problem, next, what you can do is you can define the data members as well as the APIs of the classes that you will use. Right. There are two ways going ahead. You can either start implementing the classes, or you can define the data members and their APIs. Usually, in case of a low-level design problem, you do not have to define the classes directly, because it can take a longer time, and for the scope of a 1 hour interview, you hardly get 30 to 40 minutes to implement the entire problem. Right. So we will now go ahead with the entity diagram, right? The entity structure diagram for this problem, right? So as mentioned, what we will have is, there are two ways to approach a low level design problem. One is the top to bottom approach, and the other is the bottom to top approach. So in top to bottom approach, you basically use the flow of the problem. Like you have from A you went to B, then from B you went to C, or you can start defining from bottom up approach. Bottom up means you define the individual independent data members or the classes, right? Independent entities, and then you define the relations that those independent entities have with the other objects in your system. Right. So in our case, what we will do is we will take the bottom up approach. We will define the independent components and then we will go ahead and uh, uh, define the relationship between each of those components, right? So first of all, we have a locker, right? What does a locker consist of? Locker basically contains like locker ID, right? It could be a UUID based system, right? Then the locker also consists of the order, right? This will be the order information that is currently placed inside of this locker, right? Then you will also have uh, associated with the locker a locker junction ID, right? In which locker junction does this locker belong to? Then you will also have a locker size, right? So packages vary from size to size. There could be a smaller package, or medium size package, or a larger package, right? So in order to save space and save money, you want to store a package in a locker which is more appropriate to its size, so that you do not waste any space, right? If you go ahead and store a small package in a very large box, right, large locker, so this is basically going to uh, cost you a lot of extra space, right? You were losing out on extra space which you could have used to store something else. So therefore you have to store the packages based on their size inside a locker of the relevant dimensions. Okay. Next, inside the locker, you will also have a locker status, which is empty, is empty locker. This is a boolean, right? Whereas this could be a enum, right? We could define the lockers locker size as an enum. There could be a small, large, or envelope sized, or different kinds of locker sizes, right? Uh, Other than that, there could be another there would be another important entity, data member to this entity, which is the OTP, right? Uh, so what is basically this OTP? This OTP is the current OTP to unlock or lock the locker. Unlock the locker in case if there is a package already inside the locker. So in that case, if you enter this OTP, the locker gets unlocked. But in case if the locker is already unlocked, which means that the locker is empty, so you can use that OTP and enter it to lock the locker. Okay. Next, let's define so we have used the locker junction. We will define the order locker junction ID, right? So let's define first of all the locker junction, right? So a locker junction is going to basically contain a list of lockers, right? List of lockers, right? Uh, these will allow us to check for any of the lockers inside of a locker junction. The locker junction will also have a locker junction ID, right? It will also be attached to a location, right? So that when the order is assigned to a particular locker junction, the delivery partner can use that location of that locker junction and travel to that place, right? So a locker junction will also have a locker junction location, right? So that it is easy to identify the location, right? Uh, these are mostly the data members that we will use for the local junction. If you notice one thing, we have not defined any of the APIs yet. So the APIs to enter an OTP, the API to assign a delivery partner to the order, or the API to empty the locker, right? We have not defined those because these, I have tried to create these components as dumb objects, right? Dumb objects so that they are only carrying information, and the actions, right, the performable actions are performed by manager slash controller, right? We will create a controller that could be used to handle the operations that will be done by the locker junction. What this helps us to do is we are going to reduce repetition of code, right? So that we do not define the same component, same API, same member, data member again and again, right? That is why we will be using a controller to manage the actions, right? Which are the APIs that we will expose, right? Next, let's come to our order, right? So order again is a dumb object which will have an order ID, right? In case there will also be option of a locker ID, right? In which locker does this order belong to, right? So that from the locker, from the order history itself, we can identify which locker does this order belong to, right? And then there will be a delivery partner ID. Uh, so this will be the ID of the delivery partner who was assigned this order to deliver to the locker location. Then there will be a order size, right? Item size basically. So this will allow us to match with this, right? This locker size can be assigned to the order based on the item size, right? This will also be a enum, right? Uh, right. Next, what we will have with us is a locker controller. Right now we have a locker list of lockers right inside of a locker junction. So what we want to do is we want to now define the locker controller. So locker controller is basically going to be responsible for assigning a locker to a particular order, right? You will pass in an order, you will pass in the size, and from that order size, you will check which is the nearest location for that order destination, order drop or delivery address, and you will find an appropriate or locker and assign that to the locker junction, right? So a locker controller will have a list of locker junctions, right? It will hold out all the locker junctions so that it can easily identify which is the nearest locker junction to a particular address. It will also have address access to the map service. map service. So what this map service does is this allows locker controller to access the geolocation of the uh, delivery address and helps it to identify the nearest locker junction, right? Right. So map service will be used for this. Map service we will not define in the scope and in of the interview. You are not uh, responsible for defining the map service, because map service again is a entire question for another day, right? It can take another 30 to 40 minutes defining the entire map service. So for the scope of the interview, you can discuss with your interviewer and tell them that we can use a map service which will be providing us so and so functionalities. You can use map service provided by Google Maps or Apple Maps, right? There are multiple entities which provide us similar kind of map service, right? Next, going ahead in the locker junction, we are now going to define a couple of APIs. One is to assign locker, right? Hmm. This will take in the order ID as an input, right? So based on this, it will be able to define the um, um, it will be basically able to assign a locker to this order, right? Next, we will also have the API to release a locker, right? So in that releasing of locker, you have to provide the OTP, right? You have to provide the OTP locker in order to unlock it, right? So this will be for the releasing of locker. And you can also have another API which will be to put item inside the locker. That is put package in locker. So for that, again, you will provide it the order ID and the OTP. Right. If you see now, we have defined basically two APIs which are kind of similar in nature and also have the same parameters, right? So this API will be to will be used by the delivery partner, and they will use it to put the package inside the locker and lock the locker with the OTP. And this will be used by the customer to unlock the locker and take their item out with the OTP, right? So in this case, what we could do is we could basically combine these APIs to call them order update locker status, right? So in this case, what will happen is we will take the order ID, the OTP, and the OTP, right? So this, in case if the locker is locked, we'll also take the locker ID. So what this will do is, if the locker is empty, it will lock the locker, else it will empty the locker. It will unlock the locker, right? If the locker is not empty, then if you provide it, provide this API, this details, it will unlock the locker for the customer to pick up their package, right? Okay. Next, we have defined the OTP, right? So let's go ahead and define how the OTP service will look like, right? How we will be generating these OTPs, right? So let's call our service OTP service. OTP service will only be responsible for performing a few operations. One is to generate generate OTP, right? This will be responsible for generating an OTP, and for this you will provide it the order ID. So what this generate OTP API will do is it will take this order ID, and for that order it will assign it an like it will basically generate a random OTP based on random algorithms, right? Random OTP generation algorithms we can use, and that will be used to generate an OTP for this. So later on, when the delivery agent service will assign a locker for a particular order, it will assign an OTP to this locker for the particular order ID, right? Next, for the OTP service, we also have to provide a validate OTP method. So what this validation will do is, initially we had generated an OTP when the order was out for delivery by the delivery partner, which would be used by them to lock the locker, and also it will be used by the customer to uh, like there is two OTPs sent, right? Two OTPs are sent. One one is to the delivery partner, and the other is to the customer for unlocking the locker. Now, once you receive the OTP, you have to validate this OTP as well, right? So for that, what will we do is we will have a validate OTP service which will take in the locker ID, and it will also take in the OTP that was entered by the user. So what it will do is it will check the OTP assigned inside the locker and validate it with the OTP that the user has entered, whether it is the delivery partner or whether it is the customer. This is pretty simple. Like, this is the only responsibility of the OTP service, to generate OTP and validate OTP. Okay. Now, coming to the uh, final, like near the end, we are coming near the end of this problem definition. We will also now define the delivery agent service. Now, this is a very important service in this system because this service is responsible for assigning a delivery partner to the order, right? It will have all the list of delivery partners, right? It will, so delivery partners will be uh, created here, list of delivery partners. Delivery partners will be here, right? Let me just quickly create a delivery partner as well, right? So delivery partner is basically a user, right? User ID, and other user info, right? Like address, profile information, right? Like other your uh, national security number or other unique identification ID, right? Now our delivery partner is basically uh, a child, or you inherit, you will use basically inheritance and use the functionality of user to create your delivery partner and your customer, right? You should mention this information to your interviewer so that they also know that you are using inheritance here instead of creating two different classes from scratch for a delivery partner and a customer, right? Delivery partner will have a list of deliveries completed, right? And some other information, right? Like their current location, right? This could also be stored where there could be a ping service which will every 10 minutes it checks the location of the delivery partner, right? So this is that. Customer will have a list of orders, right? Customer can also access the get order API, right? Wherein they can get the list of orders that they have ordered previously. Okay. Now, coming ahead back to the delivery agent service. So delivery agent service is going to have a list of our delivery partners, and what it will do is it will hold API to assign delivery partner, and we will provide it the order ID. Okay. So what happens here is when you provide it the order ID, what is the responsibility of this API is this API basically goes ahead, checks, first of all, it calls the generate OTP service to generate an OTP, right? It reaches out to the locker controller to assign a locker, right? It also assigns that OTP that is generated in the locker, right? So first it calls basically it will call the assign locker, right? So what it does is it gives it a locker ID, which is the locker in which this parcel has to be placed, right? Then what it does is it generates OTP. So this will store the OTP in the locker, right? Okay. So this is that. And once the delivery partner is has arrived at the locker junction location, they have identified the locker in which they have to place the package. Once they place the package, they have to enter the OTP to deliver it to the locker. So mark delivery complete. So they call this API mark delivery complete, in which they pass in the order ID, the locker ID, and the OTP. So what this API does is it basically calls the validate OTP service and passes in this order ID, locker ID and the OTP to validate whether the OTP that is entered by the user or the delivery partner is correct or not, right? So that if it is correct, they can mark the delivery status of this order to something like delivered to locker junction, right? So in this way, I will update one more data member to the order, which is the order status, which is again could be a enum, right? There could be different types of order status like uh, shipped or basically arrived at locker, or it could be something like out for delivery, out for delivery, and delivered. So delivered is when the package is picked up by the customer from the locker junction. Okay. So when the delivery agent calls this mark delivery complete API, they will complete their part of the delivery, which is to complete the order, right? What happens after this is there is one more OTP that needs to be generated, which will be sent to the customer as a notification so that they can use that OTP to unlock the locker when they come for delivery pickup. Okay. So for this, what you can mention to the interviewer is this API will basically push the order information into a queue, into a publisher queue, like a Kafka queue, or in Google Cloud, you have a PubSub topic, right? It pushes that order ID into that queue. And from there, the OTP service can be used to generate another OTP. There could be a cloud function that is written and it generates a OTP for that order and assigns that OTP to the uh, locker again, right? It could again call this API to generate OTP, and basically it assigns that OTP to the locker, right? So this is the delivery agent part of the thing. Now, when the customer will come to the locker junction, they also have to enter the OTP. So for that, they will they will also need to access this locker junction and enter the OTP in the locker. So for that, you can have a user controller, right? You can have a controller, or basically we can define that information in the customer itself, which will be to unlock, basically pick up order. So this will, in this, they will provide the locker ID and the OTP. Okay. So here we have again defined the locker uh, ID and the OTP. So what customer can do is they can call this API, provide this information, and unlock the locker system, right? But there is one thing that we have to note here is we have these APIs in return will call this update locker status, or basically they will call the locker controller. Both the customer and the delivery agent service will call the locker controller to access the locker system and check whether there is an item inside the locker, validate the locker with the OTP, and if it is locked, it will unlock it, and if it is unlocked, it will lock it, right? So in this way, you do not have to define the APIs again. Okay. So the mark delivery complete will only update the order status, and the locker mechanism will be handled by this API. Similarly, for the pickup order, you will only handle the order status part of things, and it will internally call update locker status to uh, unlock the locker for picking up the order, right? Now, to bring all of this together, we will define our locker system service. So locker system service is basically our parent service, which will have an instance of the delivery agent service. It will have an instance of locker controller. It will also uh, have information about our OTP service, right? It can use that OTP service for basically marking the users as basically generating OTPs, right? So these services inside the locker service can communicate, right? The instance of this can communicate with each other and perform their duties, right? This is mostly it. So I'll just recap the problem statement. We had defined the core entities of our problems, the actors, right? Then while defining the problem statement, we focused on defining first dump objects. We took a bottom up approach, defining the independent components, and then tried to form a relationship with the dependent items, and uh, tried, the main aim was to not repeat our code, define the APIs multiple times, and instead each API can uh, be used inside of a controller and define it only once, right? So this was mostly it for the Amazon Locker system. I'll catch you guys again next time for another fun, interesting problem statement for a high level design or maybe a low level design, right? Catch you later. Thank you guys.